We're talking about movements today. Why? Because I was in Geneva a while back and I uploaded a video about Tudor where I indicated that I wasn't particularly impressed by their new GMT METAS movement. I just didn't think it was particularly important, and that was potentially a controversial statement. So we have to have a talk about mass-produced movements, when they're important and when they aren't. Let's dive in. The core technology or engineering for watches hasn't really changed for several hundred years. You have a spring with an escapement that controls the release of the spring's energy in a systematic fashion, which feeds through a set of gears that turn the hour, minute, and seconds hands. The escapement is found a whole lot of different types, but in this day and age, you're likely only going to find two of those escapements in modern watches. It's a lever or coaxial. I'll go out on a limb and say 99.9% of modern watches are likely going to be one of those two. And then there's Roger Smith that does something else. That's what a mechanical watch did in 1810, and that is what it does today. It's not fundamentally changed. Developing a movement is still challenging. Most small brands will source their movement from Sellita or Seiko or somewhere else because building a movement from scratch is expensive. The hard part to start with isn't the gears. The hard part and the reason to innovate on movements comes down to a couple of things. It's about getting the movement packed into the right size. It's about generating and storing enough power. It's about making it consistent in its power release. It's about reducing friction, and it's about making it resistant to wear and tear. It's also about making it shock absorbent and anti-magnetic. And in some cases, it's also about making the movement visually appealing, which is not what I'm going to focus the most on in this vid. This is only about mass-produced movements. So what's the deal with in-house movements and movement innovation? When you buy a Sellita or a Seiko movement, it costs you X dollars per movement. If you want 10,000 movements, you pay X times 10, plus maybe a discount. There's no R&D investment, and you've just spread the cost of the movements out on the number of watches you've produced and hope you'll sell enough watches to cover the costs. When you develop a new movement, you have to do all sorts of research and development. There's the initial computer design of the movement, the prototyping, there's the component selection, there's the testing, there's the reworking and the preparation for scale-up of the production process. Oh, and there's also the purchase of the machines you need to build the movements. From a cost perspective, the first movement you sell costs you, I don't know, for argument's sake, $1 million. That's why that Olympic Aquaterra with the fully new titanium movement costs so much. It's not just for bragging rights. It's because there's a ton of research and development that went into that new movement. Anyways, in our fictional example, you sell your watch for $4,000 and you've still got $996,000 in losses. You sell your next watch and you're now $992,000. That's how you conceptually have to think about it. From an accounting perspective, you work with those numbers in different ways, but this is essentially what you're doing. You have a massive upfront outlay that you have to recoup across future sales. And that front outlay is largely the biggest cost of the movement. The actual movement production is potentially not super expensive. Just think of the fact that some manufacturers reportedly find it cheaper and faster just to pull out the movement and throw in a new one when it's being serviced than actually just servicing the movement. That says something. Anyways, the first takeaway from this whole explanation is there needs to be a reason to invest that money in that new movement. If there's no reason, the movement will not even make it to the drawing board. So how do you make money on a movement? Let's assume that you see a reason to build that movement. How do you get your money back? You recoup that outlay by turning 3 dials. Dial number 1 is the overall retail price of your watch. The more you can charge, the faster you recoup your investment. Dial number 2 is partially out of your hands, but it is, of course, how many watches you sell. And finally, dial number 3 is about how long you keep using that movement as it is. The longer you use that movement, the more time you have to make a profit on the movement until such time that the movement is an almost inconsequential total cost of the watch. When you put all those 3 dials together, you've got a strong incentive to raise the price because you're not necessarily in control of how many watches you sell, and you want to keep reusing that movement for as long as possible. So why do you build a new movement? That's going to depend. Now, in the case of Tudor, reason number 1 was ETA was probably going to stop selling the movements at some point. So it was Sellita or somebody else, or they had to go in-house. Reason number 2, Tudor are likely control freaks, just like Big Brother Rolex. And by bringing everything in-house, they can do everything exactly the way they want it. That subdivides into optimization, differentiation, and design constraints. Optimization is how materials are expensive, and looking at how you can make your movement cheaper or in other ways easier to produce is a key driver of costs. It's also about differentiation. The Powermatic movement from an ETA comes in at least 3 different versions and 3 corresponding prices. The cheapest version has synthetic parts and is likely never going to be serviced, but rather just replaced if it ceases to function. From there, you have better grades of the same movement. So the cheapest movement goes into the cheapest watch, and the best version goes into the, relatively speaking, best watch. That's the one that's going to have the perlage and the anglage and the blued screws. It's also design constraints. It's not just Bulgari that build a thin movement so they can produce the thinnest watch in the world. A key to Tudor going to thinner cases was also thinner movements. Going to a smaller case form factor, both in terms of diameter and thickness, depends to some extent on the movement inside. Reason number 3. Tudor made the calculation that they could charge more for in-house because most buyers can be convinced that in-house conveys quality and quality demands a higher price. For this conversation, let's just table the whole what is in-house and is Konisi in-house when it doesn't say Tudor on the company logo. I don't care. It's not important in this context. The last reason, though, is key. Tudor and any other brand do not care about innovation in movement technology in and of itself. For them, a big part of the decision is dependent on whether or not that investment leads to Tudor being able to be perceived as more valuable, better, or more desirable than whoever they see as competitors. They are banking on people feeling that the offered movement offers more than competitors' offerings, and so much more that they can make a bigger profit. Whatever the reason, every time that movement gets updated, there's a little extra bucket of research and development that needs to be recouped for that producer. So there will be a corresponding incentive to up the price of the watch just a tad every single time. New, better movement, higher overall watch price. And then there's METAS. METAS is an organization or company that externally approves movements on a whole bunch of parameters. It's not just movements, but the watch as a whole. It's accuracy, anti-magnetism, robustness, all this kind of stuff. Until recently, the only brand that used METAS was Omega. METAS is seen as the superior and more expansive certification to the more common COSC accreditation. And it is. There's no disputing that. But it's also a Swiss certification, which means no German brand like Nomos or Lange or Glashütte is going to be METAS certified. Those Grand Seiko movements, they're not METAS certified either, because Grand Seiko is not Swiss. Rolex also isn't METAS certified. METAS is not an industry standard. It's something Omega pioneered to gain credibility in terms of their technical prowess. They used it to say to the world, our watches are that good that we trust an external company to test and certify our watches to the highest standard. And it worked. Ask a watch enthusiast, and they will often cite coaxial METAS Omega movements as among the best mass-produced movements in the world. Why did Tudor get their watches METAS approved? Market differentiation. Nobody in their space at this time uses METAS. A lot are COSC certified. Some are certified in-house. By going METAS, they communicate that they are better than their competitors. And one more thing, they also communicate that they are as good as Omega, who are priced significantly higher. That's why Tudor is doing this more than anything else, to convince buyers that their movements are better, and we could stop here, but it would be missing the point, because I don't care about what Tudor wants me to feel. I want to know what real-world benefit I'll actually get from a METAS movement. The cycle of improvements and market competition has led to movements with 70 to 120 hours of power reserve. Accuracy is down to 0 and 5 seconds of deviation. You've got massive anti-magnetic properties and impressive shock absorption. The Omega coaxial escapement in itself is a fabulous innovation. I love these innovations. It's just like a CPU or a faster NVIDIA graphics card. I value that investment that a watch producer puts into those movements. It's both objectively and subjectively worth it and worthy of admiration. We've got better watches as a result of those companies investing in developing both new movements and updating existing movements. This is also what happened with Tudor. Their METAS movements are a result of design constraints. The Black Bay GMT is now only 12.8 millimeters thick, and the Black Bay 41 is also thinner in its newest iteration compared to the previous ones. And that's partially a function of changes to the movement. Not just, there's also some case things, but the movement also contributes. But on the other hand, there was a time in computing and phones where every year that new phone was markedly faster, more efficient, more capable than the one from the year before. But not anymore. I've got an iPhone 12 and I will only be replacing it when the battery dies. I don't use the camera for anything more than what I demand of it. The phone is fast online, it can play all the apps I need, it never crashes, I never feel it's slow, and it's, 4 years old. The vast majority of users have little to no benefit from the raw performance improvement in the latest iPhones or MacBooks. They are faster, but it's just not as important as it used to be. Marques Brownlee would agree with me. Just check his videos on MacBook Pros and M3 chips. And that's my first issue with METAS and the Tudor METAS movement, diminishing returns. METAS is the uppermost certification a Swiss watch can get. It's an incredibly stringent process, and I don't question for a second that it's incredibly impressive. But I don't need METAS to the extent that Tudor wants me to believe. METAS to me is the same as the deep sea challenge from Rolex that has a water resistance of 11 kilometers. It's unnecessary. It's bragging rights for the manufacturers. 15,000 Gauss is a massive amount of Gauss that few people outside of CERN will ever get near. The Earth itself generates somewhere between 0.5 and 0.9 Gauss. A MagSafe charger puts out 50, maybe 100 Gauss. In practice, the real-world usefulness of this is relatively limited for most people. Water resistance. Again, I've never had an issue with jumping in a pool with a watch that had a stated rating of 100 meters or more. I didn't need METAS to confirm this for me. 0 to 5 seconds of accuracy is impressive, but at cost levels, which is -4 to +6, I rarely, if ever, notice whether my watch is running slow. I appreciate the fact that METAS tests at different levels of power reserve, checking how consistent the movement is at different levels of winding. But again, it's never been a problem in a cost level watch. Out of the 80-something thousand seconds you have in a day, you have, by going from COSC to METAS, like a 0.01 to a 0.005 accuracy improvement. It's technically impressive, just like a Bugatti Veyron that can do 400 kilometers per hour. But this isn't a Richard Mille, an F. Pigeon, or an Octo Finissimo for hundreds of thousands of dollars. This is a mass-produced, mass-market watch. So, yay? It's also the same movement. Specifically for Tudor, it's the same movement. The METAS movement is architecturally and materially unchanged from the movement that came before it. The difference is the little u at the end of the model number. And this is significant because it's the same materials. So the non-METAS movement was already as anti-magnetic as the METAS movement. The non-METAS movement in that case was already as water resistant. The non-METAS movement was already shock resistant. You're basically getting two things from METAS in this specific case. You're getting a more stringent timing accuracy and more strict conditions, and you're confirming that any microscopic deviations in the composition of the materials do not affect the already assumed anti-magnetic and waterproofing properties. I completely acknowledge that Tudor has had to tighten their production standards to ensure that those movements pass the tests. But odds are they're pretty confident that their movements were so good that most movements were going to pass. It's like me betting with a friend that I can drink 5 pints in under 10 minutes when I know I did it twice last weekend. Finally, it's Swiss. I'll concede for a moment that a lot of people will appreciate the external approval/certification that METAS brings. To that, I'll ask you, what's your opinion on Deutsches Institut für Normung Standard 8330? The watch manufacturer Sinn conform to different DIN standards depending on whether it's a watch to be used in aviation or on a submarine. In Germany, they use DIN standards. Buy a German watch and they'll follow the German DIN standards. Deutsches Institut für Normung doesn't sell tickets in the way that METAS does, but it largely serves the same purpose at a fraction of the cost of that METAS chronometer approval. Is DIN any good? Depending on the DIN standard, anti-magnetism tolerances and other elements are not always as stringent as METAS. But that's where I refer back to my initial argument of real-world benefits. DIN 8309 is 4,800 Gauss. That's still a lot. And at the end of the day, Sinn conforms to the DIN standards. Remember that, Sinn. You can trust the Swiss to find a way to make us pay more for putting a special branding on something, be that Swiss-made chocolate or watches or METAS. By the way, next time you're in Geneva, be sure to check out the cocoa plantations. They are all along the shores of Lake Geneva. It's quite the experience. All of those things put together, and I'm not particularly appreciative of METAS, especially because of the consequences of that certification. It's down to the fact that it's more about Tudor building a case for charging more for their already good watch for little real-world improvement. The thing I appreciate about the Tudor movement is that it contributed to a thinner case. That's important. That's a real-world benefit. The METAS stuff is a way for Tudor to kick Omega in the shins. The METAS stuff is bragging rights that cost me more money with little to no real-world benefit over a decently built COSC movement. It's genius business strategy from Tudor. They now have a movement that marketing-wise differentiates itself from COSC-certified Sellita movements that are more and more becoming the standard in so many watches. Now, don't draw the wrong conclusion. I'm not a troglodyte that doesn't care or appreciate technological innovation. I want watchmakers to push the limits. I appreciate, the Bulgari movement that is now the thinnest in the world. I appreciate how some brands have succeeded in making perpetual calendar movements affordable for the masses. I also appreciate the coaxial escapement. I want movement innovation. The Kinesi MTU movement is a good movement. So is the 8900 from Omega, the Caliber 400 from Oris. Zenith has a Defy Extreme that has 2 separate power supplies for the movement and the chronograph function. That's also impressive. I've grown to appreciate Lemania-based 321 movements and the 1315 movement of the Blancpain 50 fathoms. That would be, for me, a reason alone to buy the 50 fathoms, despite the fact that the watch is over 14 millimeters. It's 120 hours of power reserve with 3 barrels, and it's got all sorts of other tech that's cool. But what will I pay more for? Assuming that COSC is the standard, or DIN A330, assuming that 60 or 80 hours of power reserve is standard, I don't need any more there. You know what I want? I want chronograph movements that aren't modular and thick like bricks. I want an Omega or a Grand Saga or a Tudor chronograph that allow for a consistently sub 12.5 millimeter case. That's something I'll pay for. I'll pay for a sub 11 millimeter case with an automatic movement. I dream of having more micro rotor movements so I can see more of the movement. I also want instant change dates at 12 o'clock precisely. And if I want one party feature, give me a 5 Hertz movement with a 10-year service interval. You know what I'd also like? A guarantee from manufacturers that they will stock parts for my movement for at least 25 years. Those would be meaningful movement innovations for me. So that's why METAS branding isn't as important to me as Tudor would like it to be. I want movement innovations in mass-produced movements, but I want the ones that are relevant for me as a consumer. I also want a couple of party features, but I don't want the ones that just drive up the price with limited real-life improvements or benefits. As usual, I've got a strong opinion. You are free to voice a difference of opinion. So what's your stance on METAS and DIN and COSC and Japanese movements? What would you like to see more in terms of movement feature sets? Let me know in the comments. Like, subscribe. Cheers.